Okay, so finding angle measures for parallel lines and with these angles. We talked about corresponding angles, but again, if you did lesson 14, you know there are other types of angle pairs. There are what we call alternate interior angles, alternate exterior angles, and same side interior angles. Okay, so let's recall alternate interior angles are between the lines. Okay, so that's why these are labeled. They're on opposite sides of the transversal. So here's my transversal. 1 is to the left, 3 is to the right. They're diagonal from one another. The postulate says that those are also congruent. So alternate interior angles are congruent. Here we have another pair, 2 and 4. 4 is to the left of the transversal, 2 is to the right. They are alternate and interior because they're between our parallel lines. They are also congruent. Okay, so the alternate interior angle theorem says alternate interior angles are congruent when the lines are parallel. Alternate exterior, they're also congruent. So what makes them exterior? Well, notice here's our parallel lines. They're outside of the parallel lines. They're not between them. They're on the outside. Okay, so what makes them alternate? They're on opposite sides of the transversal. So 5 is exterior because it's outside of the parallel lines, but it's alternate from 7 because they're on opposite sides of the transversal. One's to the left, the other's to the right. They are congruent. Okay, that's another new property. 6 and 8 are also a pair of alternate exterior angles, and they are also, which makes them congruent. The ones that are going to mess you up are the same side interior angles. Interior, again, means between your pair of parallel lines. So here's our parallel lines. We're just looking at the angles that are between those. We're not looking at these up here that are outside or exterior. Okay, so the thing about same side interior angles is they are on the same side of the transversal. So they're both on the left or both on the right. They are not congruent because they're on the same side. They are supplementary. They add to be 180. So angle 1 plus angle 4 equal 180 degrees, and angle 2 plus angle 3 equals 180 degrees. Okay, so that will be the property that probably messes us all up, only because all of the other angle pairs are congruent. The only ones that are supplementary are the same side interior. Okay, down here we have a figure. It says if the measure of angle 5 is 80 degrees, I'm going to go ahead and put that in there in my figure. So angle 5 is 80 degrees. Find the measure of all the other angles in the figure. Well, we can do that. We can do it in a couple of different ways. We can use corresponding angles. We can use alternate exterior angles. Notice angle, this 80-degree angle up here. Okay, it should be congruent to this angle down here because they're alternate exterior angles. It should also be congruent to angle 7 because those are a pair of corresponding angles. And in our previous section, we talked about corresponding angles are congruent. I know those are all 80 degrees. From there, I can say, well, this one should be 80 for two reasons. One, it's a vertical angle with angle 5, and 2, it's alternate interior with this angle 7 that we just filled in. So angles 5, 7, 4, and 2 were all congruent. What will the measure of the other angles be? Well, we know these same side interiors, so angle 80-degree angle here and the 3 here, are supplementary. They should add to be 180. So if I take 180 minus the 80 I have, I know that this angle here, angle 3, should be 100 degrees. And it's congruent to this one up here because they're corresponding. It's congruent to angle 6 here because they are alternate interior angles. And it's congruent to angle 8 down here for either vertical angles, or angle 6 and angle 8 are corresponding, so they're the same. So again, notice by knowing one angle in the figure when we have a parallel line and transversals, we can fill out all of the angles and their values because of these theorems. Okay, let's use those theorems to find to solve a problem. Okay, it wants us to find the measure of angle ABD. Let's take a look at where angle ABD is located so we know what we're trying to find. A to B down to D. So this corner right here is what we're trying to find the measure of. We know it's 2x plus 10, but that does us no good because to get an answer, if we need to not have an x in there, we just need a number. So what we have to do is find an equation that will let us solve for x, so we know what the number x is, and then we can put it back in to find the measure of angle ABD. Well, looking at this example, notice we have a set of parallel lines, and we have the angle on the interior of the parallel lines. So it's an interior angle. So I know either these are going to be supplementary, add to be 180, or they're going to be congruent. If they're alternate interior, they're congruent. If they're same side, they add to be 180. Well, notice this one's to the left of the line, this one is to the right of the line. So I know that they are alternate interior, and alternate interior angles are congruent. So congruent means equal. So I can set them equal. 2x plus 10 should equal 3x minus 15. And now all I have to do is solve to find x and plug it back into my angle. All right, to solve, we have to get x by itself. So we'd subtract 2x from both sides so that we get the x's on the same side. 3 minus 2 is just a 1x. Now that x is all by itself, I need to move everything else to the other side. So this minus 15, I need to do the opposite of subtracting 15 and add 15 to both sides. When I do, I get x is 25. Okay, so now my job still is to find the measure of angle ABD. It was 2x plus 10. Now that I know x is 25, I can substitute that in and find my answer. I know it's 2 times 25 plus 10, or 50 plus 10. 2 times 25 is 50, plus 10 gives me 60. So I know that ABD is a 60-degree angle. So I had to use my theorems to set up an equation and solve for x, and then after I knew what x was, I could substitute it back in to find the measure of angle ABD. Hey, let's try a couple of others just to practice those. What's the measure of angle 1 going to be? So again, make sure you keep your theorem straight. A lot of angle pairs are congruent, but there's one type that was supplementary. So what type do we have? Well, here's our pink parallel lines. The 133 angle and the angle 1 are inside, so they're interior angles. Then we just need to know, are they same side interior or alternate? Well, here's our transversal. Are they on the same side of the transversal or opposite sides? They're both above the transversal, so they are same side interior. And what did our theorem say about same side interior? Same side interior are supplementary. So I know that my angle 1 plus 133 degrees should be 180. And I can find angle 1 by subtracting 133 from 180. When we do that, we get that angle 1 is 47 degrees. Okay, next example, what's the measure of angle 2 in this picture going to be? So again, your first job is to figure out what type of angle pair am I working with? Well, here's my pair of parallel lines. I know that because of the arrow markings that they're parallel. I have a transversal cutting through those lines. Well, notice the angle 2 is between the two, and the 70 degree is outside of the two. So one's interior and one's exterior. Okay. Okay, so they can't be alternate interior, alternate exterior, same side interior, because one's outside of the pair of lines, the other is inside. What we call that is corresponding. These are corresponding. Notice the 70-degree angle is in the top left-hand corner of its intersection up here. Okay, here's its intersections. It's the top left-hand corner. Angle 2 is also in the top left-hand corner of its intersection. They are corresponding, and we know that corresponding angles are congruent. So angle 2 would be equal to 70 degrees. Okay, here's one more. Let's try